Hello. This video, Part 2D, is to complete where we left off at the end of Part 2, derivatives of sine and cosine functions. This is essential for understanding pendulum equation and dynamics. In Part 2, we derived formulas, highlighted here in blue, for sine and cosine of alpha plus beta. Please commit those rules to your memory, which will be easier to do if you understand how we derived them. See Part 2, link below. Also, stay tuned for next video, Part 2E, where practical examples will be presented. We want to add small variation to the argument x. Let's apply above rules. In Part 1, we discussed approximation for sine and cosine functions of small argument. It's repeated here, highlighted in red. In upcoming video, Part 2E, we'll touch on this topic as well. Stay tuned. We now have all we need at our disposal. Let's find variation of sine and cosine caused by variation of x, denoted by Greek letter delta. This is the convention. Focusing on terms linear in delta x, ignoring higher powers of it. Thus, we find derivative, defined as a limit of the variation quotient. It's good to remember. First derivative of a function, in fact of any function, denotes its instantaneous rate of change, the slope of the tangent line. This derivative is also a function of the same argument, generally speaking different from the original one. A derivative of the derivative is called second derivative. It denotes curvature, also called concavity, of the function graph. It is rate of change of the slope. The third derivative would mean rate of change of the concavity, and so on. For most applications, we don't need to worry about third and further derivatives. Local extreme, max, or min of a function, where sign of slope changes, is a point where the first derivative is 0. Point of inflection, POI, where sign of concavity changes, is a point where the second derivative is 0. This is true for any function, not just sine and cosine. But for sine and cosine, the derivatives first and second appear beautiful in their simplicity. First of all, let's remember that functions sine and cosine are essentially same, just shifted in phase. Please refer to Part 1, ABC, link below. And here's the most beautiful rule of today's video. The second derivative of a sine or cosine function is equal to negative of itself. Suppose any physical value of any object changes with the time as expressed by the below formula. The multiplier to time t, denoted by the Greek letter omega, highlighted in red, is called frequency, more precisely, angular frequency. Many values in physics pertaining to anything oscillating can be expressed by the formula at the bottom, highlighted in blue. Denoted by letter C is the amplitude, and by the Greek letter gamma is the phase.